Hello students, today I am back with another video. Today we are solving a PYQ of JEE Advanced 2019 paper 1. This is a question on parallel plate capacitors with dielectric between the plates. Let us read the question quickly. A parallel plate capacitor of capacitance C has a spacing d between the two plates having area A. The region between the plates is filled with n dielectric layers parallel to its plates, each with thickness delta is equal to d by n. The dielectric constant of the mth layer is Km is equal to K into 1 plus small m by capital N. For very large number capital N, which is greater than 10 power 3, the capacitance C is alpha times K epsilon naught capital A divided by d ln2. The value of alpha will be. So for the aid of the students, I have made a diagram over here. So we have n plates between the plates of a capacitor. We have n dielectrics, sorry. And each dielectric have a different dielectric constant. The fourth dielectric constant, for example, will be K into 1 plus 4 divided by N. And they are telling N tends to 10 power 3 and beyond. So we need to find what is the capacitance of this system. To be specific, after finding capacitance, we need to report the value of alpha. So yeah, let's dive into the question. Let's first learn about the key ideas that we need to solve this question. So the first key idea we'll use is the definition of capacitance itself. The definition of capacitance is charge on the positive plate of capacitor divided by the potential difference between the plates of the capacitor. Very simple. So capacitance is the ability of a conductor to store charge per unit potential difference. Beyond that, we will be using what will be the electric field inside the dielectrics. If E naught is the electric field in free space, okay, in the vacuum, if the electric field is E naught, and if you suddenly insert a dielectric in that region, the electric field is going to get reduced by K times, where K is the dielectric constant. So basically, electric field inside a dielectric will be E naught divided by K, where E naught is the electric field in vacuum and K is the dielectric constant. I hope this is clear. Let us move on to the next key idea. Now, let us use these ideas that we have learned in calculating the dielectric constant of a capacitor, or to be more specific, the capacitance of a capacitor which has multiple dielectrics between its plate. Let us say this particular question has n dielectrics in its plates. So if E naught is the dielectric in the absence, if E naught is the electric field in the absence of dielectric, then in the presence of dielectric K1, the electric field will be E naught by K1. And inside the dielectric K2, the electric field will be E naught by K2 and so on. So now, if we recall, what is the relation between potential difference and electric field? Potential difference is the integral, negative of the integral of electric field. So what did I do with the negative sign? I have changed the limits of integration from positive to negative instead of negative to positive. Which in case of constant electric field, we can write it as sigma E dot D. Instead of integral EDR, we can write sigma E dot D. Because in our case, we are having constant electric field in each of the dielectrics, right? So we'll just replace it by sigma ED. So the total potential difference between the plates is going to be E1 D1 plus E2 D2 plus so on up to En Dn. Which we already know the electric field between the plates of a parallel plate capacitor without dielectric would be sigma by epsilon naught or Q by A epsilon naught. So let us replace E1 by E naught by K. But E naught is Q by A epsilon naught. Correct? E naught is Q by epsilon naught. So E1 will become E naught by K1, which is Q by K1A epsilon naught. So on doing that, we'll get Q1 by K1 epsilon naught A into D1. Similarly, here you will get Q by K2 A epsilon naught into D2. Now, we will calculate the capacitance by definition of capacitance. It is the charge on the positive plate divided by potential difference between the plates. We have calculated both. We will substitute that and we will see that the effective capacitance of a parallel plate capacitor with partial dielectrics would be epsilon naught A divided by summation of all the D divided by K's, where D will be the thickness of each dielectric and K will be the dielectric constant. So using this formula, we have the capacitance of this parallel plate capacitor system that is given in the question. Now that we have the capacitance of this parallel plate capacitor, let us solve the question. So we have the C effective that we just derived in the previous section. But interestingly, they have told us that your number of dielectric plates will be exceeding 10 power 3. And 10 power 3 is very large compared to 1. So we can say that n is very closely tending to infinity. Compared to 1, 10 power 3 is very large. So n is tending to infinity. So C effective can be written like this. Epsilon naught A divided by limit n tends to infinity, sigma I equal to 1 to n, summation from 1 to n, D divided by, I have replaced Ki by K into 1 plus I by n. Right, this is what is given in the question. And they have told that the thickness of ith place is D by n. So now what I'm going to do, we are going to use the fundamental theorem of calculus, which says that infinite limit sum is same as integral. So we will calculate the limits of integral. If I put I equal to 0, I get I by n equal to 0. And if I put I equal to n, which is the upper limit, we will get I by n equal to 1. So we have to integrate from 0 to 1. So the infinite sum, so D by K is a constant, I'm going to take it out. I plus 1 by n, 1 plus I by n will transform into x, 1 plus x, and 1 by n will transform into dx. So now what we are going to do is, we are going to integrate this. This is a very simple integral. You must have done it many times in your mathematical course. Integral of dx divided by 1 plus x. The integral comes out to be ln2. All other terms I have kept as it is, k epsilon naught a by d ln2. So after solving, we realize that the value of alpha that is mentioned in the question is equal to 1. Okay students, so here is your challenge question or the modified PYQ like your previous question. The question is as follows. A long cylindrical capacitor has an inner conductor of radius r and an outer conductor of radius 2r. The space between the conductors is filled with a dielectric whose dielectric constant varies radially. So here we do not have multiple dielectrics with different dielectric constant. We have a continuously varying dielectric constant and it's radially varying. That is mentioned in the question. Where r is the distance from the axis, the potential V is applied across the conductor if the length of the capacitor is L, where L is much greater than R. The capacitance is found to be C is equal to beta times 2 pi epsilon naught L K naught divided by ln of ln2. This is given. However, due to the nature of the logarithmic function at small r equal to capital R, we consider the dielectric to be valid only for the region r plus delta to 2r, where delta tends to 0. So they are telling determine the value of beta by evaluating the limit of capacitance expression. So for your aid, I have also made a diagram over here. In our next video, we will be solving this particular question. So please stay tuned.